Good morning, good afternoon, good evening. Welcome to another episode of the StackRox Office Hours. This is episode 3, and I'm here with Mandar Dawaktar to talk about Kubernetes network policies. I'm Chris Short, your host with the most here on Red Hat live streaming. Mandar, introduce yourself to the audience. It's your first time on the channel, so feel free, divulge.
Thanks, Chris, for the short introduction. Hi. I'm Mandar. I work with the Red Hat Advanced Cluster Security team. I joined Red Hat via the acquisition of StackRox. And I've been with StackRox for just over 2 years and contributing to almost all the components of StackRox, network segmentation, policy management, risk computation. And outside my work, I enjoy being active, trail running, cycling, kayaking. So if you are in the Bay Area and want to join in with me, hit me up.
Nice. Things I used to be able to do. So Kubernetes network policies. There's a lot to them, right? But you're going to break it down for us. So how do you want to do this?
Cool. So what I'm going to do is share my screen and kind of walk through a short and sweet demo, not too complex. Basically, it will take us through how to write network policies and what are some things to look for when you're writing and enforcing network policies. All right. So first of all, what are these, what is a Kubernetes network policy, right? So in the simplistic terms, it's basically a means of controlling inbound and outbound traffic, from the pod's perspective, right? To other pods or to the internet, right? And this is achieved via something called as labels and selectors and widely used by various Kubernetes resources, right, such as services as well. So Kubernetes network policies and Kubernetes like the pods are very they're like the network policies are like the guiding angels. Whatever is the label, the network, and if the network policy kind of sees it, satisfying it, it will just stick to it. So that is one very crucial piece that is also important in identifying how are you going to segment the applications, right? So what I'll do now is basically jump into demo. So basically, let's create a namespace so that I can, show whatever I, yeah, good, yeah. So by default, no network policies are, enforced, right? I mean, there are some CNI plugins or managed Kubernetes services which deploy or claim to deploy default network policies, but those are essentially allowing all the inbound and outbound traffic, right? So basically it's it's not enforcing, or it's not limiting any traffic, right? So it's as its behavior is as there is no network policy, right? And Kubernetes network policies being namespaced has actually a huge advantage, although there are some limitations, but it also has a huge advantage. When we are thinking Kubernetes has been a game changer in how we deploy and maintain applications, right? Or even to a certain extent, how we write applications, right? Yeah. Everything is very application centric, right? And the basic principle being, the applications or the pods serve the purpose and disappear, right? And with this namespaced kind of environment, multiple teams, having these different namespace working in their own namespaces kind of allows you, provides this natural way of segmentation. And that is something, one needs to keep in mind when writing Kubernetes network policies, and how you can take advantage of network policies being namespaced, right? We will talk about some limitations and how we can, overcome them later during the demo. But for now, let's get started with that. So what I'm gonna do is I'm gonna create a very simple environment, mocking. There's like a database, there is a middle layer or the service layer, and there is a front end, the typical okay. Okay, so we are running into problem.
What is the DB supposed to represent?
Okay, so we were missing NS.
Okay, got it.
All right. So so we have our DB. I mean, it's essentially an Nginx and app, which for demo purposes, I'm treating it as a DB. Then let's say we have a catalog service. Let's say this is an application which is serving which is basically serving. Okay, so the issue was we did not create it in the namespace.
Ah,
right. All right. So, okay, let's get to what we have. Oh, interesting. Okay. So there is a syntax error here.
Pod deleted.
So what I ended up creating
should be like a band name.
Yes, the first rule, right? All right. So let's. All right. So let's create the service called catalog, which is basically acting something like providing a catalog of products. And so what we have is now we have two pods. One is behaving as a database, it's an Nginx Alpine, and one is behaving as catalog, right? So right now, there is no network policy enforced in this particular namespace, right? So if I go into, if I exec into one of the pods,
Namespace.
yes, that is correct.
There we go.
And let's say we try to hit, google.com or something like that. I'm able to reach out. I'm able to reach out to the internet. I should be able to reach out to the other, pods. However, right now I've not exposed any other pod, as service. Like, so what I'll do is I will expose DB on port 80. Okay, and of course we are up. Oops, there. Okay, so let's get all the pods again. However, let's also figure out what, let's look at the IP addresses, the cluster IP addresses that are associated with them, and as well as let's look at, what are the services that we have now. All right, so if I go back into catalog and try to get DB, I should be able to reach to it. Okay.
Nice.
So basically this, what it's demonstrating is I deployed my applications, right, without enforcing Kubernetes network policies, right? and it's not controlling any traffic. It's open to the entire internet, and communicating, open to any kind of intrusion and
Right.
Unwanted things, right? So there are two approaches to this. When you're writing Kubernetes policies, right? You can start off by having a deny all policy in place, which means basically deny all the inbound and outbound traffic, right? When you're deploying a new application, let's say in a test environment, like it's not going to be used immediately, right? And what you want to understand is, okay, you want to see how your application is, kind of reacting to that deny all policy, right? How is it failing? Where all it's trying to reach. And another good thing to accomplish this is to have good logging, right?
Right.
Whether if it is failing, if silent logging, or whether it's crashing and things like that, right? But the other side of the coin is writing Kubernetes network policies can be a daunting task, and I agree to it. Many a times, developers, kind of shed the responsibility to the administrators, and there could be a possibility that there's no proper check between how the applications are moving forward.
Right. Yeah.
The other approach is like put it in a test bed, with allow all, and observe how the application is behaving, for let's say a window, where all the application is trying to reach. So this is going to be your baseline, right? And identify if that baseline is even something that you anticipated, or even something that you expected.
Yeah.
Right.
There could totally be something wrong with the image, maybe reaching out and grabbing the wrong package kind of thing. Anything's possible.
Exactly. And then kind of reverse engineer, kind of scope it down by putting in place, some network policies, and things like that. So for example, what I'm going to do now is let me first show. I have a deny all policy here. Okay.
Pretty simple, yeah.
Pretty simple. It's selecting all the pods in the namespace demo, and not allowing any traffic, right? So another point I should be touching on is network policies are basically like based on the rules of allow list, what must be allowed, right? You cannot have rules such as, block only XYZ connections and allow everything else. You need to be explicit on what you are going to allow, what you want to be allowed, right? So since there are no rules here, essentially it's telling like, allow, like we don't have any rules, so kind of block everything. So what I'm going to do is take that policy and apply.
It's going to be angry. It's going to rebel.
Yes, I'm going to lose my I'm going to lose my TRP, my customer base, when they're trying to shop from my wonderful catalog.
Yes.
So
my catalog has a very beautiful index file in it.
Correct. So let's go back and try to hit Google. If I did everything right, we should expect this to time out. Right. Okay. You're bad at this, right? We can also try to reach out to the other pod.
Nada.
And it should be all right. Cool. So right now we have like a completely isolated namespace. Any new deployment or any existing deployment or pod in this namespace cannot have an inbound or an outbound connection to anything else, right? So this is like, in ideal world, you would start here. You know how your application is supposed to behave. So you start from the most restrictive network policy and then kind of move outwards, right? So as I already exposed the DB service, and I want my catalog to basically query the DB and like get some records out of it. So basically, what now I need to do is allow ingress on DB, like from catalog, right? So that I can
explicitly allow those two.
Exactly. So that I can fulfill those queries. So let's try to do that. I have pre-built this YAML file. Writing YAMLs are kind of sensitive. I can understand a pain, like even an indentation could make a huge difference.
Don't you have a tool for that? I feel like
yes, there are. I would actually want to touch upon a tool that I came across and I've been using it, which kind of elevates some pains of writing network policies. But yeah, we'll get to it.
Okay, cool.
So let's look at this policy. What this policy is informing, right? So it will be enforced in the namespace demo, and on the pods which have label app is equals to DB, right? And it's an ingress policy, right? Telling that, okay, allow all the ingress from the pods which are labeled app is equals to catalog. And this is the scenario we want to support right now, right? So let's just go ahead and apply that policy. All right. So that's the DB policy. All right. So let's see what all policies we have now in this particular namespace. Demo. All right. So as you can see, there are like two network policies, right? One is denying all the traffic. One is allowing traffic to the pod DB, right? So one would question, like, how, what is an effective network policy? Like, what should happen when I have multiple network policies, right? So one thing is out of question, like I created both these policies scope to this namespace for this namespace demo, right? So the namespace policies, the effective namespace policy is basically the disjunction of all the rules. So basically, if I have a policy saying, okay, do not allow any traffic, ingress traffic. And if I have another policy saying, okay, allow ingress traffic. So it's like a true and a false, right? A disjunction. What's gonna happen is the effective network policy is going to allow ingress, for that particular pod. So that's how network policies work. And how it plays, how it is important is, like, one needs to pay attention on how you're writing network policies. Like, keep it simple. Don't write a network policy which is trying to address everything. Like having 100 lines of 100 rules in it. Don't make it too complex, because
complexity leads to mistakes.
Exactly. Network policies being, kind of a challenge in the first place. If something breaks, it's going to be difficult to identify, how it's, what rule is breaking, things like that. So have network policies scoped to the functionality, like what's it's supposed to do. If it is supposed to work on a pod, like let's say in this case, a DB pod, scope it down to that deployment, that pod. Is it supposed to allow ingress traffic, egress traffic, and have those things, have those segmented out, so that you can revoke, like take out some network policies if something breaks, and work your way through debugging. right? So the first, one of the important rule is, try to keep it simple, right? So I have an ingress policy. Does that mean let's try to reach out to DB? Okay, let's see if it's going to work. Right, it's not. Okay, let's pick up the IP address and try to get to it. Okay, so I have an ingress policy on DB, but somehow I'm not able to reach it via catalog, from catalog. And the answer is you have umbrella network policy blocking connection for all the other pods.
Yeah.
So now what I have to do is I have to explicitly add a network policy to allow egress from catalog, right? So when you're writing network policies, it's almost like you define the behavior on both the ends. You have an ingress policy on one side on a pod. You kind of have to have like a egress policy, a complementary egress policy on the other end with which you want to communicate with this. So what I'm going to do,
it's two-way communication. So
yes,
policies.
exactly.
Yeah,
exactly. And the reason why is I started off with the most restrictive policy, right? If I remove that restriction, right, deny all, I can reach to DB from catalog, and we can walk through that as well, right? But since I'm starting with the most restrictive policy and I'm opening one door at a time, I know what I'm doing. I know what I'm opening up, right? Through these explicit rules in the network policies, right? So I have this network policy for catalog. Again, it's saying allow all the allow the egress from catalog to the pods having label app is equals to DB, right?
The port numbers 53.
That's a very good observation there.
Okay, thank you.
Writing ingress policies has been is traditionally kind of straightforward, but when it comes to egress policies, it becomes slightly challenging because for one reason being, one may not know how the application is exactly behaving. What does it take for the application to work properly? Where does it need to reach out? Does it need to reach out to GKE bucket to get some data for at startup time? But the most primary thing is most likely it will it has to reach it has to be able to reach to DNS server, right? To be able to resolve what the pods and external endpoints as well. So if correct, right? So if I do not have this rule, right, basically, if I try to reach the pod, using the name, right, it's going to fail, right? Because I cannot reach to the DNS, and that's the most important note to make, right? When you're writing an egress policy, make sure you can reach to the DNS server, right? Whether it be kubedns or other DNS servers that you're used, make sure you're not blocking that, right? Now there are caveats of this rule. Basically, it's allowing traffic to all the pods on port 53. You can scope it down, by labeling the kube system namespace, and kind of making the rule, translating the rule to only reach out to kubedns in kube system namespace. But for now, I'll just leave it as is and move ahead. All right. So let's apply that, and now we have three policies. We have an ingress policy on DB. We have an egress policy on catalog. Let's go back and see if we can reach out to, yes. So we could reach out to the DB pod, right? And we could reach out to the DB pod, not using the IP address because we have not blocked the path to the DNS, right? So this is, this is like a very simple kind of demo I had. I have like a couple of more network policies here. I would specifically like to, maybe show another one, right? So as I said, YAML can be confusing. This is another form of
more than one way to YAML a cat. Yeah.
Yes. Right. So, so it's I came across like there's a very good meme out there which says like, oh, there's like a Kubernetes which like a cat is wearing right?
Yeah,
and
yeah.
It says like, oh, you said like just YAML would be sufficient, right? But it's not the case. So both are essentially denying, the traffic both ways on all the pods in this namespace demo, right? But like there are different ways how it is written. So knowing, like, testing out the network policies is always critical. What you're writing, the YAMLs, it's very important. Like you test out, how the YAML that you have written, ends up being, right? So yeah, I mean, this was the short and sweet demo I had. Yeah, and let's. I mean, this is an office hour, I believe.
Yeah. Folks, if you got
go with the flow.
Yeah, if you have questions, feel free to ask them. So Amanda, in your example, you open port 53, but I feel like there's a better way to do that, right? Like I would just open up port 53 to Kube DNS, Kube system, to the API on port 80 or 443, depending upon the situation. I mean, how else can you like make that rule better, tighter, kind of thing?
That's a good question. So let's open up that YAML, right? So there are some prerequisites to do that, right? Since network policies are tied to labels on the pods. First of all, you need to make sure that if you want to scope it to something, make sure that that particular pod has appropriate labels, right? Generally, users create namespaces and do not label them. Folks like label pods, deployments and other things, because most likely they'll expose it through services like load balancer and things like that. But namespaces, right? So then you also got to like label the namespace, right? So let's actually try to do that. Let's see if I can actually do that without. Okay, so we have Kube system. Okay, so I'm going to list the pods in the Kube system, right? So we have the Kube system sting right there. Let's describe Kube system, okay, and see if it got anything. Nope. So we have this label namespace metadata StackRox IO Kube system. So I have StackRox, the advanced cluster security instance, running in this particular Kubernetes cluster, which applied the label. We do that, but otherwise you wouldn't see this label. So let's pick that label and kind of work our way how we can scope down the DNS rule, right?
Mm-hmm.
All right, so what I want to tell it is namespace. Okay, so scope it down, right? So I want to scope it down, match the label. Oops, blah, blah, blah,
Yeah.
right? Namespace is equals to so and so, right? So
Yeah.
now what? So now we have scoped it down slightly, right? So what it's telling, what this network policy is informing is allow egress traffic to port 53 for all the pods, to all the pods in namespace, carrying this label, right? All right. So it's still like, okay, you can still reach out to all the pods in kubedns namespace, right? So we might need to scope it down further, right? So let's say, let's describe, what kubedns looks like. Right, so, all right, okay, so huge.
Oh, yeah, yeah.
So there's a label here which we can likely use, Kate's app is equals to kubedns. Now, I want to also talk about, labeling, what are some basic rules or tips that one should, be aware of when you want to segment the network policies, or basically your applications. All right, so I'm going to cat it again so that we have it on the screen. All right, so what we have now is we have a network policy, scoped down to pods having Kate's app is equals to kubedns label in namespace having that particular label, right? But the caveat to this is, although I've scoped down my network policy, and if someone is going to add a pod with the exact same label, it's going to start allowing egress traffic to that label as well, right? That pod as well, right? So there are two parts to this, right? Writing network policies, enforcing network policies, and how you write those network policies. But the other part is enforcing who can write a network policies and who can label resources in your environment, right? Otherwise, anyone having those permissions to introduce new network policies or introduce new or update the pods with new labels can basically go around the wall that you're trying to create, right? And there are a couple of ways to kind of achieve that enforcement. You can have an admission controller in place that kind of restricts, creation of, like updation of those resources, or like creation of network policies, or you can also use like Kubernetes RBAC rules to basically kind of scope down, who can do what, right? Like, remember the principle of least privilege. The
Right.
way you're going to achieve security is by adhering to that principle, right?
Mm-hmm.
For example, if I had these network policies in place, right? And then if I, let me just show, allow all. If I go ahead, if someone is able to apply this policy, all my effort is waste.
Right.
Right. Because it's going to allow all inbound and outbound traffic,
Right.
to this particular namespace. Right. So there are like, so that's another important thing, how you are going to complement the network security through network policies is kind of having some kind of enforcement and adhering to the principle of least privileges, so that people cannot go around that wall you're trying to create.
Yeah, don't hit the apply all rule. Question in chat here: how can we make? I mean, what is the right network policy and to make that accessible to the world? That catalog pod.
So
and I know that involves ingresses and RBAC and all that fun stuff, but is there a network policy for
that? There, unfortunately, no. It's because network policies are something application aware. Like they're meant to be application aware. They're meant to be focused on application, right?
Mm-hmm.
What works in one environment? Well, let's say you have Cassandra and things like that, and what works for that particular environment may not work for other environment. But there are these basic points, right? What to look at, right? Let me actually go to that, right? Like this slide. Okay, now this is not an exhaustive list. I've just tried my best to list a couple of things which I feel are important to look at when you're writing network policies, right?
Mm-hmm.
So first of all, you don't want to block reaching out to Kubernetes API server, right? DNS, like the DNS servers, that your application is going to depend on. The ports that you want open, so that if it is serving workloads on the internet, you want to keep them open, right? If you have exposed it behind a load balancer, maybe you want most likely you will want to have these health check endpoints open, so that you can know whether your services, your apps are healthy, things like that. So there are some basic things that one can start at and work their way towards it. And again, reiterating, one can deploy the application in a test bed, observe how it's behaving for a certain time window, and identify how, whether it's meeting the expectation, right? And kind of reverse engine, start your way backwards, start scoping it down. So definitely, I mean, testing network policies is a crucial thing. You do not want to break applications in production.
Right.
Yeah.
Don't start testing things on prod.
Right. but I also want to highlight one thing here, network policies, the declarative nature of Kubernetes and how you write applications, or how you kind of deal with the resources in Kubernetes. I think it's in a way kind of pushing developers to, kind of start moving the security from administrator to the application development. Basically, those who are developing application know the architecture of that application and how that app is supposed to behave the best, right? So it basically shifts enforcing security in the early phases of applications life cycle, right? It could very well start in during the development of the application as well, right? So that's I see it as an advantage. I see Kubernetes network policies and the nature of it being the declarative nature of it being an advantage, to allow anyone to enable the developers to kind of take that responsibility, shoulder that responsibility to enforce security early on.
So somebody's asking how to do this with a route, and of course I'm going to link to documentation for that. So let me just do that real quick. Yeah, so routes in OpenShift land are like an ingress egresses in Kubernetes land. They actually predate ingress. So this is something that Red Hat had to create to satisfy a customer need when OpenShift was launched. So route specific security annotations and things like that are all documented on this page, I feel like. And locking things down there is as easy with a admission policy. So making sure that the ingress is good to go. It's not opening things that it shouldn't have open. And you can do that with a number of different
and
routes
I mean,
and ingress types.
Yeah. There are not everything is green with network policies. Like there are some pain points, right? Like network policies are namespace
Right.
scoped, right? Scalability, right, is one of the challenge, right? You, for example, the standard DNS, like allow egress traffic to DNS, is something probably would be natural to throughout the organization, right? And teams deploying their applications in different namespaces, might most likely, want to have that template, right? So there are, there are these CNI plugins, and different managed Kubernetes services have, different choice of CNI plugins. But these CNI plugins have something called as like global network policies, or like cluster level network policies. Each CNI plugin uses different terminology. That kind of addresses the concern of scalability, right? Let's say if someone wants a workflow such as, when any application that is deployed must, must allow egress to, the DNS servers of that organization, things like that, right? So these CNI plugins kind of enable it. And the Kubernetes network policies work hand in hand with like these network CNI plugin, the CNI specific network policies, right? So it's a complementary feature, and most CNI plugins have things like visibility as well, right? Like you have deployed a network policy. What next? Should you sit back, right? That's something always get asked, right? Like how do I kind of observe the environment, and how do I kind of adapt, and how do I update my network policies? For example, like Cilium has a very awesome network observability. I'm not sure whether it's like a paid thing or not, but they have like some logs, network policy logs, which basically have like custom metadata telling, okay, which network policy allowed or denied a connection from what pod to what pod, things like that. I believe, it's because, there's eBPF, and eBPF has been like, you'll see it being used in more and more places, because the enriched data that you can get using that has been advantageous. I think GKE data plane v2 has that feature as well. Cilium has, Calico also introduced that. So Kubernetes network policies, limit the limitations, look at, CNI plugins, their network policies, to kind of reduce the repetitive work of, let's say, a CI/CD pipeline, things like that, and observability, right? So that's another important aspect to that.
Very good point. I just linked in chat, folks, to the last episode where we talked about eBPF and implementing security and monitoring around Kubernetes with it. So feel free to check that out at your leisure. You can always find us at our webpage, which is just simple link here. Live streaming. If you could type today, that'd be great. So yeah, no other questions from the audience. I feel like, Naveen, if I haven't answered your question, please let me know. And I'll ask Mandar, but he was asking, how do I get things out of the cluster, basically, or have access to things if a connectivity failure occurred, like
So
between, I guess, I'm thinking he means between nodes, but
how do you like diagnose if there is a connectivity failure?
Yeah, like he wants to know what's the source IP. I'm confused by the question. So
all right,
I'm trying to answer it while being confused by
let
it.
Let me put out some couple of points. So can you access the audit logs, the Kubernetes API server maintains a log of all the requests that are coming to it, right? I mean, essentially, when I'm running a kubectl, create namespace or create pod, it's essentially a REST call to the API server, right? And everything gets logged in there. Managed Kubernetes services, if I'm not wrong, most likely have the the logging feature turned on by default. So that's like one good starting point. And network policies are not going to deny or not going to block any communication between the pods and the node that the pod is residing on, right? So if you can get onto the node, you can run kubectl, and if you're having admin privileges, you can kubectl and kind of diagnose, get the application logs and things like that.
So I've got a question in here. Does StackRox, or now Advanced Cluster Security, help automate the management of these network policies rather than having to manually create them?
That's a good question. And yes. I would love to show StackRox or ACS. Let me share my screen.
Awesome.
All right. Let me know if you can see the Advanced Cluster Security. Okay, cool. So one of the most talked about feature of StackRox is network observability, network segmentation, right? As you can see here, I'm not sure if you can see where I'm hovering, but basically top left, there are like three kinds of views: active, allowed, and all, right? Okay. So the active view is basically showing all the connections that are active right now, Right. So that's like a good way of, of observing, like, how my applications are connecting. Let's say this is a test. Basically, I'm testing out, how my application is communicating, this is the view. We provide details about, what port and whether it's an egress connection, the protocol and things like that. We also added support for a kind of scoping or making it explicit to which CIDRs your application is trying to reach out to, outside your cluster. So this is about active connections. So coming back to that question, right? So a loud view kind of provides that the space of how your applications, or what all kind of connections your application can have, right? As you can see, like, there are different, let me zoom in. So these boxes or the squares are namespaces, and these filled circles or dots are your pods and deployments. and each of them is having like a different legend, right?
Right.
So basically, as you can see, if I hover over DB, if you go back, like I had a ingress policy in place for DB, and it would only allow connections from catalog. Right. And you can see, right, it cannot reach out to the external world. You cannot see that arrow, right? So same thing, like other part. I think this was the one which I created. Now you can go to Network Policy Simulator. Let me filter down first so that it's. Okay, so we have this demo cluster and the associated namespaces. What you can, you'll see multiple options here, and what you can do with these is first view what are the active YAMLs, right? So these are the policies that I applied to the namespace demo, right? So I can see what are my network policies in this particular namespace. I can edit those network policies and upload them here and see how it is taking effect, how it's changing, right? So there are ways to basically like upload network policy, right? Okay, let me see if I can navigate to the folder.
I believe in you.
Allow all. I believe we had not applied allow all.
No, we did not apply that, but all of a sudden your DB can talk to the API server, and that seems crazy.
Right. So this is another way to make sure like how your network policy is behaving and whether it's kind of meeting the expectation without breaking the application, right? And then you can like tweak the network policy if it is not meeting the expectation, scope it down, scope it up, and then see it. And then you can also apply it, right? Like if I apply this, it's going to start allowing connections to it's basically going to allow all the ingress and egress. So StackRox provides a very good tooling around, alleviating those pains of writing network policies. You can also generate network policies. Let's say you did not have any network policy or you had some network policies in place. You can select a time window. Like let's say I want to generate a network policy based on the connections made to the app in past hour, right? So I go to Network Policy Simulator, click Generate and Simulate Network Policies. It says, no network policies are needed to be created or deleted because literally I have an allow all.
You have everything open, so yeah.
So this is a very good, tooling from StackRox to kind of, play with network policies, and build network policies.
That's awesome. So you can kind of just say, look back at this sample of 24 hours, see what's happened, and only allow that. And it'll all be right there for you. That's awesome.
Exactly. And StackRox, has a couple of more things like network baseline. So this demo has not been running for a very long time. I just spun it up right before this meet. So basically something like we have an observability window during which we observe the connections to an app and kind of lock it down, and any new connections, or any connections deviating from that baseline are highlighted as anomalous connections, to basically asking you, hey, is this something you anticipated? If you anticipated it, okay, you can mark it as a baseline, you can move it to the baseline. If not, then probably you will need to update your network policy because someone is trying to reach to your app, right?
Yeah.
So that's another cool tooling from StackRox, to observe beyond the period of like, you have applied the network policies, but what next, right?
Yeah, and like, can StackRox highlight abnormal activity?
So right now,
or I should say advanced cluster security. I'm sorry, I keep saying StackRox. Advanced cluster security.
I'm wearing a StackRox sweatshirt.
I know, it's throwing me off.
We do not analyze packets. So we observe connections. We observe the connection information, basically the endpoint, like the endpoint information, the protocol and things like that. We do not perform analysis on packets like, we have like, I know there are some, there are like these firewalls which perform packet analysis and kind of block or allow connections based on that. It's not that granular, but what we want to make sure is you can see the connections coming from an endpoint and make a decision whether that endpoint can be trusted, allow it or don't allow it, right? And once you have that rule for that connection, and since network policies are basically like sitting at the edge of the application, like the guarding angel, right? Even if someone kind of breaks into an app, a pod, it makes it difficult for to move laterally, go to the other apps and kind of make
that blast radius gets a lot smaller the tighter those policies are.
Exactly.
Like allowing, some people do have or intermix, dev and stage and prod across a fleet of clusters. Not that there's anything wrong with that, but usually prefer prod on its own cluster. So you wouldn't want your dev stuff talking to your prod stuff, or even your stage stuff potentially, right? Like, or there would only be one kind of lateral movement of package, that's been tested and done from your CI system into the various environments. So yeah, there's a lot of power and a lot of potential here.
And I believe that has been the underlying principle with things Kubernetes, right? It has made it more explicit, why namespaces, why application focus, why things need to be focused around applications. It's because it should be in that way, right? Your application is driving, should be driving, the decisions on, like what's the environment it should be talking to and things like that.
Right. And, I've said this to some ops people before. It's like Kubernetes forces you to understand applications better, right? Like you kind of
makes it more evident.
That point.
Exactly.
And that's how it should be, right? Like we shouldn't be saying, hey developer, what VM size do you need? And that be the extent of the knowledge that we have of that system, other than patches that are applied to it or whatever. Like we should understand the traffic coming in and out of it. We should understand, syscalls to an extent of what's, being called, and if that's, valid for that application. So doing the profiling is a really good feature, right? So you can actually sit there and say, hey, developer, can, if you're not the developer looking at it at the time, you could go back and say, hey team, is this expected? Like, this kind of looks weird to me. Is that legit or not? Because you never know, right? Like
Kubernetes has been game changer. I have to agree to that.
So you've got some resource links here, and I'm going to share the slides after we're done here, folks. So
awesome.
Don't worry about that.
I would like to make some like special mentions of the couple of things. There are like a couple of blogs written by my colleagues. They've also been submitted to CNCF around what are the best practices for writing ingress and egress network policies. And this GitHub resource is something that I love. This person is, I guess, network policy enthusiast, and he has put out a bunch of samples, recipes, like of network policies and how they behave. I would recommend everyone to like check it out, and it's good in kind of understanding and learning curve. And I mean, I put out some resources here, but definitely this is not an exhaustive list, and I do not want to stand behind any particular managed Kubernetes service or a CNI plugin. But like these are some most commonly used CNI plugins and managed services. So good starting point if someone wants to look at the CNI interface and things like that. You can go to their GitHub. I've also put links to network policy logging. That is something new, addressing the question like, how should I detect intrusion? How should I adapt my network policies?
Yeah. That intrusion detection bit is pretty awesome, because normally that's done like at your network edge, and being able to do it right there in clusters. Great.
Right. So last but not least, you definitely we look forward to contributors to the StackRox community. You can go to stackrocks.io, reach out to us, write blogs, like if you have any cool ideas on talks, things like that. And if someone is interested in looking at Red Hat Advanced Cluster Security product, you can go to this link and request a demo. I guess you can also reach out to me, and I can kind of moderate and forward that email to appropriate people. And
yeah,
we are hiring.
We got jobs, folks.
if you love Kubernetes and if you want to work in security space, definitely go to this link, put in the keywords advanced cluster security, and you will see a list of openings. Our team is looking to hire good engineers. So either you can go there, or again, you can reach me out at like LinkedIn or any other means, and I'll make sure it's conveyed to appropriate people in the organization.
Awesome. Well, Mandar, thank you so much for coming on. Really appreciate your time today. This has been an awesome demo. Great work. And we'll see you. We'll see y'all in next month. I think this is a monthly show. Last I checked, I forget.
Yes.
So many shows. So yeah, folks, if I don't see you between now and next time, stay safe out there. And Mandar, thank you again for coming on. Really appreciate it.
My pleasure. Thank you, Chris, and have a great day.
You too.